twice. Okay, and then of course there's a lot of verbiage. You select 5 numbers from the digits 1 through 53 and a Powerball number from the digits 1 through 42. To determine the winning numbers of each game, lottery officials draw 5 white balls out of a drum with 53 white balls and 1 red ball out of a drum with 42 red balls. And then we go on. Compute the number of ways the first 5 numbers can be selected. Well, so there are 53 balls. If you pick a number, do you put it back? No. So we're sampling without replacement. The real question is, how many ways can you choose 5 balls out of 53? And the answer to that question is
53, choose 5.
Right, 53, choose 5. So A is simply 53, choose 5, or 53 times 52 times 51 times 59 divided by 5 times 4 times 3 times 2. Let's see. Okay, that was not quite as good. That doesn't work. Huh. I think we can cancel out
4 into 52, 13.
12? No, 13. And that doesn't work. Does this work? Yeah, that works. That's 17, right? Okay. So what is that number?
2,869,000.
How much?
2,869,685. 2,869,685.
685. Okay. And then there's really only one way that you're going to match all 5 white balls, right? So the probability of winning the prize of 100,000 is getting exactly those 5 balls, and therefore the probability of that happening is
That right there.
1 in.
1 in, right? That's just 53, choose 5, inverse. C. What is the probability of winning the Powerball jackpot? Well, again, we just apply the FORAN rule. The probability of the jackpot is the number of ways we can get those numbers divided by the total number of ways numbers we can get. There's only one number that satisfies, getting all 5 white balls and the red Powerball, right? So first, we start out with the 53, choose 5. But remember, for each red ball you pick, there are 53, choose 5 other white balls that will give you a different set of 6 balls in all. And how many ways can you choose 1 ball out of 42? Exactly. 42 choose 1. So that's then equal to 1 over 42 times 2,869,685, or some number. Which I can't do in my head. Anybody have that number? Very small. Not the 100 million. See, it's a very valuable thing we're learning. Probabilities of learning, calculating lotteries. Yes.
Is that the probability of, is that JP?
Jackpot.
Oh, got
Me being late. Or one could see it as me not inflicting you with the pain of my own handwriting. 58, the Dallas IRS auditing staff. That one?
Mm-hmm.
Okay. Concerned with identifying potentially fraudulent tax returns, believes the probability of finding a fraudulent return, given that the return contains deductions for contributions exceeding the IRS standard, is 0.2. Given that the deductions for contributions do not exceed the standard, the probability of fraud is 0.02. If 8% of all returns exceed the standard, what is the best estimate of the percentage of fraudulent returns? So, a problem like that I find much easier to address if you impose a little bit of structure, and specifically a probability table. So, you've got two different situations. You have actual fraud, or no, you don't. You have exceeding deductions, and you have fraud. So we've got fraud, let's just call that F and not F. We have exceeding deductions and not exceeding deductions. Okay, we're told that the probability of no we're not. We're told if 8% of all returns exceed the IRS standard. So 0.08 go there. We know there's one here, so the only other thing we can fill in is what? 1 minus 0.9. Very good. So 0.92. And we can't do anything else until we look at the rest of the information. The probability of finding a fraudulent return, given that the return contains deductions for contributions exceeding the IRS standard, is 0.2. What kind of probability is that? Is it a marginal probability? And it's not a joint probability. Remember, both marginal and joint probabilities can be put on that table. Conditional, very good. So this is the probability of finding a fraudulent return, so F, given, they literally use the word given, so that's a clue, that the return contains deductions for contribution exceeding the standard, and that's equal to 0.2. But by definition, this conditional probability is equal to the probability of F and X divided by the probability of X. So we're given this part in the problem, we're also given this part, so the only thing we don't know is this joint probability. And we isolate that and find that the probability of F and X is equal to the probability of F given X times the probability of X, which is 0.2 times 0.08. So this is that right? 0.08, 0.2. Yeah. So that is 0.016. There we go. We're then told that the probability, given that the deductions for contributions do not exceed the standard, the probability of fraud is 0.02. So we can do the exact same thing. The probability of, let's just skip to the actual solution. Let's see. So this is F and not X. That's then equal to 0.02 times the probability of not X, which is 0.92, which is this is going to be on how we use the information. Very typically, you're given conditional probabilities, and you just have to, put up the formula, do manipulation, and that leads to an answer. So we've got 0. 4, The question was, what is the best estimate of the percentage of fraudulent returns? What do you think? Say it?
Thank you.
So the percentage of fraudulent returns is the same thing as the marginal probability of picking out one at random that is fraudulent. And so you can read from the table.
0.0344. But question is, do we prove that not X?
It is, you're not interested in this exceeding the standard or not when they're just asking what the best estimate for the percentage of fraudulent returns. So yes, definitely. Other questions? Is that a hand? Tim?
Yeah, the not X don't seem to add up unless I just added them all.
Here?
If they, yeah, wouldn't
Well,
that,
that could be I did this in my head, so.
oh, I'm sorry.
Did I do it wrong?
Here's, so they don't add to 0.92, but the,
They don't? Are you sure?
oh, they do, I'm sorry.
Okay.
Are you going to post these solutions? No?
No, I never post solutions to problems, solution menus. Those we do only on the board. But you're welcome to ask me questions, I can show you answers if you want, but it's incredibly unpopular to post solutions because those invariably spread, and then you can't use problems anymore, you can't assign them. So there's, you basically get a lot of, it's considered incredibly foolish